Okay, so this time we are ready to make our own version of fancy walking. So I had shown earlier how to use the system API. The API, by the way, API stands for Application Programmer Interface. Anything that's provided part of the library, part of the system, we kind of loosely call it as API or existing method. Okay, so instead of this, so we want to provide our own way of walking. Okay, so this 0.5 meters, so we want to just kind of do the steps. Okay, so let's see, we want to kind of learn few things first. If you look at walking and if you look at a person's walking, so the one leg has to come forward, one leg has to go back, and the body has to turn, right? So first of all, let me turn Jack left a little bit so that we can see. Okay, so really one leg has to come forward, one leg has to go back, or if you kind of think about how you walk generally, one leg moves forward, the other leg kind of stays in contact with the ground, really, right? So in a sense, from the front it kind of goes back because the whole body moves, right? So the whole body moves we already have, see, and we want the legs to leg movements we want, right? So let's play with the legs. Right leg, move forward, move for half a meter. So in general, it's a bad idea to move any body parts. Okay, once you move, it will separate from the body. This is a bad idea. Okay, let's undo. So really, we want the leg to kind of turn forward and turned, really, right? So right from the hip area, so we want the leg to turn, right? So let's try turn forward. Not this much. See, if you do quarter revolution, see, wow, so it turns too much, right? So let's see, turn forward, maybe 0.1 or so. Okay, even that's a little bit too much, but that's okay. I will explain you why that's okay. Okay, so the right leg at 0.1 and so left leg. One more thing, see that we said a turn forward, leg actually went back. That's because for the leg it's kind of really facing down, really, right? So when you say forward, it kind of goes clockwise in a sense. So turn forward is you may remember in the C-plane example, turn forward means it kind of goes down, turn backward means it goes up, right? So here from the leg, this point of view, turn forward means it kind of goes down, right? Turn backward means it will come to the front. See, okay, so let's see. So now that we understand that turn forward is 0.1, let's go ahead and do that. So in addition to the walking here, I'm just thinking that what's the best way. Okay, let's go ahead and do it. Turn forward, right leg, turn forward, and 0.1. Okay, so then left leg, turn reverse direction, right? Turn backward, 0.1. Okay, so now we are including the leg movements. Let's see what happens. So in addition to the walking, body moving forward, legs are turning too. Okay, that is a very strange way of walking, right? So so Okay, that's a good start, but it does look quite funny, and that's not exactly working, right? Okay, so that's because these three statements really, if you walk, if you're looking walking, so that's good, but the next to walking they should really change directions, right? So that's how it should come, right? So these three statements, first of all, let's make them do together, okay? Because this action should happen together, okay? So now let's see what happens. Okay, that looks better, but still not what we want. That's okay. Okay, so now let's close this one. That's a step number 1, right? Step number 2 has to be reverse of this, right? So that's a step number 1. This is a step number 2. Okay, so let's see, what can we do? Move forward. Jack should be moving forward, and then the right leg, really we want to change the direction. Left leg, change the direction too. Okay, now let's see. So basically leg goes front, and kind of you're kind of standing position, and we go to that walking position, and the leg moves, right? So that's not exactly how we walk, right? That's because Jack is starting from the standing position. So if he's starting from a walking position, then he'll be better. Okay, so let's make him from the walking position. How do you make him to walking position? Well, we turn to face the tube, but also if we can make the legs get ready, go to the walking position, right leg, left leg, so just to take the first two movements, right, first step, just reverse that, or I guess you could have taken the second step, and walking positions, just go off of this also, off of it, so that way you kind of go to the walking position, then you kind of continue and do the reverse direction. Okay, so if you want to be perfect, you can kind of put this and do together. Or if you want to understand it, maybe let's not do that, let's not do that. So just keep it here. Let's see, now he turned, see, now he's in walking position. Very nice, right? So he kind of got ready, so then after that he's able to do the reverse. So he's doing reverse of the previous step all the time. Okay, so from standing position he went to walking position, and that made all the difference. See, so that's the walking position is getting ready. Now the leg that was in the back, since it turned forward 0.1, so it goes to the other end position. Okay, so you may even have to draw some pictures to kind of understand this. Okay, so let me try to explain. One more thing you can see, glitch, it's really he's really touching the tube before turning. That's because we are doing 2 steps before checking. See, before we used to do only 1 step and check, but now this time we are doing 2 steps here, right? And okay, excuse me. So here we can put the do together if you want to get ready. These are all getting ready, right? See, that's getting ready, and immediately starts walking. Okay, again you can do that as a scene setup too. So he can even turn it, and he can just be ready to walk, so this portion can be done as a scene setup. You can right click here and do that. I have just put it as a program itself. Okay, so now you can see our program is becoming reasonably complicated, right? So also we made two steps, and before doing that checks. Okay, so now it is possible to make our own steps. Okay, now that our program became reasonably big, we can call this step 1 and call this step 2. Okay, so let's see whether we can create our own methods. This is everything we are dealing with Jack, so we can go under Jack and create our own method. Okay, so I'm going to call it step 1. Okay, and one more method, step 2. Okay, so now Jack, this version, the Jack step 1, step 2, they are empty, our own methods. So I'm just going to copy this do together, which is step 1. Go ahead all the way, copy to this clipboard here, put it there, and go to step 1 and just drag it here. Okay, and similarly this one, the second do together block, step 2, copy there, click on step 2, the Jack step 2, or you can click on this edit, then you can see that method appears. And now we have step 1 and step 2, two methods are now populated with code. Now all we have to do is simply invoke it. You can delete this, delete, just drag the step 1 here, drag step 2 here. Okay, so now we are making two steps, and whatever code we had, we have put it in step 1 and step 2, and we are able to do the same thing. You shouldn't see any difference in the behavior. Okay, so strictly speaking, you can put this method anywhere, these methods, but since it was dealing with only Jack, we went ahead and put it under Jack's methods. Okay, so still we are not happy with this. See how he's kind of crossing the tube, walking into the tube and coming back. So ideally we want to do these checks after each step, right? So one thing you can do is that, well, you can make the copy of this if. Let's see, if statement right there, and one more copy of second if statement. Make a copy and move it here. So now you can see after each step we are doing both if statements, and step 1 both if statements, step 2 both if statements. Let's see whether that fixes the problem. So now for every step, right, we are checking whether we are getting too close to the tube. Okay, so that looks better than before, right? Well, but the thing is, the code wise we have duplicated the code, right? So is it possible to achieve this without duplicating the code? Okay, so let's see. So this if statements, right, they are kind of checking whether the direction change is necessary, right? So since they are duplicated, here we want to avoid this duplication. Okay, that's one of the concepts in software engineering, is that we try to avoid anytime, as much as possible, avoid duplicating the code. Okay, so we moved the steps to this two methods. Why not move this checks to one method too? Since this checks are involving multiple objects, so we will go ahead and put it under the world. Okay, so check and turn. How about that? Check and turn. Okay, so new method, check and turn. So let's go back here. If statement, I'm going to check and turn here, move that if statement here, and go back here, second if statement, and go back here, and bring that if statement. So I have drag and drop here. So both if statements are here. Now I can delete all the if statements. So we are really modularizing the program. So let's make sure they are doing the right thing. Yes, they look like right thing. So now all we have to do is, after step 1 check and turn, after step 2 check and turn. Okay, so what are we doing here? We are setting up. Remember, I told you these things can be done as part of scene setup also. Okay, then after doing the scene setup, we are doing our own methods. We do make one step, and then we immediately check whether we need to turn. Jack has to turn if we're getting close to any of the objects. Then we do the next step. Again we do the checks, whether it got too close to the objects. Okay, again if you play, it shouldn't be any different. It should be exactly same as what we had before. So just now we have managed to split the functionality and put it in separate methods. Okay, I know probably this lesson is a bit too long. Just one final thing. So the step 1, step 2, if you look at it, if you step 1 and step 2, if you look at it, only thing we are doing is this turning forward, turning backward. See, so this thing changes, turning forward, turning backward. This direction alone changes. So let's go back to Jack. I want to introduce one more method. I'm going to copy this step 1 and create one more method, step. And this step not only does this job, it's going to do the job of both step 1 and step 2. Okay, how can we do that? Well, we are going to pass a parameter to say whether it's a step 1 or step 2. Okay, let's see, how do we want to call it? Number. So instead of step 1 and step 2, we are just going to call it step 1 1, step 2 we are going to do -1. Okay, we are going to invoke it as a -1. Maybe I should show the invocation before coming here. Let's go back here. So instead of step 1, I am just going to do like this, step, we are going to pass. So then again for step 2, I'm just going to other, I'm just say did other -1. Okay, so it's kind of reverse of the step 1, right? Except the whole body is moving, it's a reverse one. So so now we are no longer using step 1, step 2, but no harm, we can leave those as it is. Okay, so remember, this is the current one. Current code for this step is same as the step 1. Okay, so effectively for the step 2, we want to change this. Of course, you can put a if statement. If number equal to 1, do this, else do the other one, right? Step 2 steps. Well, that's kind of not a great solution, because we really have thrown in the code in one place, right? So instead, what we want to do is we want to play with some math. Remember, the turn forward 0.1 revolution, it's the same as turn backward minus 0.1 revolution, right? So it's like walking one step forward is same as walking backward minus one step, right? It kind of looks confusing. Walk backward minus one step means to walk forward plus one step, right? So what I'm going to do is simply 0.1 revolutions, I put a math expression, multiply by the number. Okay, I'm just going to show you better since it's going out of the view. So here math expression multiplied by expression number. So instead of just saying 0.1, I'm just going to say 0.1 into number. Okay, so when you pass -1, this will become the -1. Turn forward -1 is nothing but turn backward 0.1. I'm sorry, turn forward minus 0.1 is nothing, revolutions is nothing but turn backward positive 0.1 revolutions, right? So I'm just showing a extreme version of the reuse. Okay, so now just making this adjustment, we are able to use the same method. We are just passing in an argument from here, so we are kind of indicator type of thing. We are not only invoking a step, we are passing in one argument, 1 and -1, a indicator. So then we are able to achieve both steps using the same code. Okay, so I know this is a little bit more complicated, little bit kind of math, but still I wanted to show that the extreme version of the methods and reuse. So we're able to achieve all the functionality using just 2 methods. Let's make sure that it is doing it correctly. Should be no difference whatsoever. Okay, so particularly for this video, maybe it's a good idea to kind of stop in between and or replay a few portions, okay, few segments, and take time to kind of do every version on your own and see the same results. Okay, thank you.